So it's a dirt problem. So I'm going to set up a dirt chart like we did before. And there are 2 trips involved with the dirt problem. What are the 2 trips for this dirt problem? You just
6 miles up.
6 up and then 6 back, right? So there's upriver and downriver. So those are the 2 trips this time. Sometimes it's 2 people driving, sometimes someone's on a bike and then they're walking. This one, the 2 trips are upriver, downriver. And this is kind of a strange one because we know so much information. We know the distance. 6 miles up took 3 hours. We know the distance back. 6 miles back down only took 1.5 hours. Well, let's think about this. We're in a river. In the kayak, the river is flowing at some unknown rate. I'm going to call that R. And then the kayak is paddling at K. Okay? K miles per hour. So here's the person in the kayak. I'm wearing a sombrero to keep the sun off of my bald head. Also, sombreros are really easy to draw from a bird's eye view. But nonetheless, the kayak is going this direction against a river's current that direction. Now, in the world of boats, we have something called SOG. And if anyone's familiar enough with boats, SOG stands for speed over ground. Because there's tides, there's current, there's wind, there's all kinds of other factors affecting your boat. So speed over ground is the speed of the boat relative to the bottom of the river. Okay? Not how fast it's going against the water, which is also moving. It's how fast is the boat going up that river. All right? Speed over ground is obviously 2 miles per hour. Right? If you're going 6 miles in 3 hours, 6 divided by 3 is 2. Now 2 is not the answer to the river's current. 2 is my actual speed over ground going up that river. But 2 has a relationship between R and K. 2 is however fast I'm paddling minus the river's current pushing me back. Okay, we're basically adding these 2 vectors together. So it's going to be my speed minus the river's current, which is going to be K minus R. I'm going 2 miles per hour in actuality, but that's found from my speed minus the river speed that I'm paddling against. Speed over ground on the way back, 6 divided by 1.5 is 4. It makes sense that I'm going twice as fast because I'm getting there in half the time, so of course I'm going twice as fast. 6 divided by 1.5 is 4, but the speed over ground, when I'm going in this direction, the nice thing about the kayak is you can't really tell which direction I'm going, so I'm just going to point the vector down. Now the river's pushing me, so I'm going faster with the current, so my speed over ground is the sum of those 2 vectors. So K minus R is equal to 2, and K plus R is equal to 4. Now, if you don't see these numbers, that's fine. You could just have K minus R, my speed minus the river when I'm going up, my speed plus the river when I'm going down the river. We always know in a dirt problem that distance equals rate times time. So 6 equals rate times time. So 6 equals K minus R times 3, and also distance equals rate times time. 6 equals K plus R times 1.5. And you have those 2 equations with 2 unknowns. Because remember, these are your 2 unknowns. I don't know how fast I'm paddling. I don't know how fast the river's current is. But I know that combination times 3 gets me 6 miles. I know this combination times 1.5 gets me back down 6 miles. So the first step that you should do when you're doing this problem is divide both sides through by 3. And divide both sides through by 1.5. Because what that does is those give you the speeds over ground. 6 over 3 is 2 equals K minus R. 6 over 1.5 is that 4 we talked about, equals k plus r. Because what happens on the right? Everything cancels. Everything cancels on the right. Then you get these two nice nifty equations. All you got to do is add them together. 2 plus 4 is 6. The r's cancel and you get 2k. Divide through by 2 and k equals 3. That's how fast I'm paddling. I'm paddling at a rate of 3 miles per hour. That's how fast I'm going. So if I was in a lake with no current, I'd be going 3 miles per hour. But the river's affecting me such that it's slowing me down to 2 and speeding me up to 4. So the river's going to have to be, if I plug it in right here, if I plug in k equals 3, 4 is equal to 3 plus the river's rate r, subtract the 3, and there's the rate of the river. The rate of the river is 1, which makes sense. If I'm paddling downstream at 3 and the river's pushing me 1, 1 plus 3 is 4, and if I'm going the other way at 3,